This is CPM Calculus, Chapter 2, number 138. Examine these scenarios and pay attention to the units. So we're asked to pay attention to the units. Okay, so let's go ahead and read part A. While walking to school, Jaime's distance from home in miles was S of t is equal to 3t squared, where t is measured in hours. Sketch a graph of his distance. Okay, so let's sketch a graph of his distance. So we know that the graph of 3t squared, so this is going to be time in hours, and this, our y-axis, is going to be distance in miles. Okay, so since we're actually looking at something in real life, and we can just graph this. So 3t squared to the right is going to look like this, right? It's a quadratic, so it's a parabola on the right. And on the left, it would look the same. But since we're actually talking about somebody in real time, we know time starts at 0. We don't have negative time for Jaime, so we're just going to look at the graph starting at 0. So this over here, we can erase even. Okay? We can erase all of this. So there is the graph that I'm going to sketch for his distance, right? S is his distance, and we're done with that. So if it took Jaime 30 minutes to walk to school, so if t here is 30 minutes, right? What is his average velocity? So we know that 30 minutes is equal to how many hours? We know that's half an hour, or even we could say 0.5 hours, okay? So here on our graph, at 0.5 hours, what is going to be his distance there? We plug in 0.5 into this distance formula right here. We get 0.5 squared is 0.25 times 3 is 0.75. So we know, so this tells us that he gets home at, he walks to school, he gets to school, and he lives 7.75 miles away from school. Okay, so it takes him half an hour to walk 0.75 miles. So now we're asking, what is his average velocity? So what is his average velocity? So remember, when we're looking at average velocities, we're basically going to look at, since the beginning, from the beginning at time equals 0 to time equals half an hour, how far did he travel and at what speed? So we know that he travels 0.75 miles in half an hour. So basically our average velocity is going to equal that. So let's just plug this into a formula that we know. We want to start at our final velocity. So V average is equal to basically the change in velocity over the change in time we're looking at. So we're looking at the velocity at time, what? 0.5, minusing the velocity at time 0, and dividing by the delta t. Well, the change goes from 0.5 hours to 0 hours, right? So the velocity at time half an hour we already saw was 0.75. The velocity at time 0, well, that's 0, and 0.5 minus 0 is 0.5. Okay, so we plug this in our calculator. 0.75 divided by 0.5 is going to be 1.5. So his average velocity is 1.5 miles per an hour. Okay, so there's the sketch of the graph, and this is how we get the average velocity between time 0 and time 0.5 hours. Okay, let's go on to part B. While walking home, Jaime walked so that his velocity in miles per hour was v of t equals to negative 2t, where t is measured in hours. Okay, so remember that when we're talking about velocity, we are looking at a vector value which has magnitude and direction. Okay, so when we're looking at versus speed, we just have magnitude. Okay, so I want to bring that up at the beginning. Okay, so we're given this. How long did it take him to get home? Well, let's graph this. So here, for part B, we know that here's time on our x-axis in hours, and now we have velocity on our y-axis in miles per hour, right? And the velocity, let me use a different color, is going by this equation. So at time 0, our velocity is 0. Again, I'm not going to look to the left because we're starting at time 0. At time 1, our velocity is going to be negative 2 miles per hour, right? So we just have a line, or actually a ray, going down like this, right? So as we keep going on our time, so now we're asked, how long did it take him to get home? Well, we know how far is his home from school. So we know from part A that his home is, we know that he goes 0.75 miles. So we know that the delta D is equal to 0.75, right? Well, what do we have in our graph? So let's look at this a little bit careful, like more in depth. And we see that we have the velocity over time graph right here. And if we want to look for distance, well, we know the area under this curve is going to equal his distance traveled, right? So if at this point right here, let's say right here at TH, let's say T sub H is his time he arrives home. If this is his time he travels home, then the area under the curve from 0 to TH is equal to the distance he travels in that time, right? So let's just write that out. The area under the curve equals the distance traveled, right? So, we're just looking for the time of like him getting home. So if we know that it takes him 0.75 miles to get home, and that's the area under the curve, well, the area, so that has to equal the area under the curve, right? Between time equals 0 and time equals time arriving home. So what does this curve look like? So to find the area under the curve, it's basically what? It's a triangle, right? The triangle with base being what? If we look at it as an upside down triangle, the base here, this distance is going to be T sub H, right? T sub H. And the height of the triangle, we can look at it right here, is going to be our velocity at T sub H. Okay? But the area is calculated as base times height divided by 2, right? For a triangle, we're looking at dividing it by 2. Okay, so on the left, we still have 0.75. Okay? So then we can just substitute in V at T sub H into this equation, and we get T sub H times, well, do we really care about velocity? So I'm going to speak about the negative right here. We don't really care about the velocity, we just care about the speed. So in actuality, we don't care about velocity, so we just need the magnitude, not the direction. So I'm going to put an absolute value around that because we don't care if it's negative or positive, we just want to know how fast he's going, right? So I'm going to multiply that by the absolute value of 2, and then I'm going to plug in for T sub H, divided by 2, right? So the absolute value of negative 2 T sub H is going to just be positive, right, 2. So it's going to be 2, and then T sub H times T sub H is T sub H squared. and then that's still over 2, and on the left we still have 0.75. Okay, these 2's cancel out, and we're left with 0.75 is equal to t sub h squared. So to find his time when he gets home, we square root both sides, and we plug that into our calculator. 0.75 square root is going to be 0.866025438. So that 0 here is going to round this by nothing to leave it as 0.866 is equal to t sub h. And we know that the units of this is in hours, right? So let's write our answer in a sentence. How long did it take him to get home? It took Jaime 0.866 hours. We can even say approximately, right? Because I rounded here, so let me even add the approximate symbol to get home from school, 0.75 miles away. Okay, so a little sentence here goes very far in explaining to the reader of this problem after you complete it exactly what you're doing and you know you're answering the question. Okay, so this ends chapter 2 of CPM Calculus number 138.